So just for the next 30 minutes or so, this session's going to cover a bit of an overview of the Climates programme. I'll come into a bit more detail in terms of what the programme is, but the programme, or the title, Building Resilience Through Innovation. So I'm going to put a bit of context behind why we've done what we've been doing. Talk a little bit about the opportunity that we've identified around that as well. Talk a little bit about what we've done, what we've achieved, and ultimately what our ambition is and where we're heading to go. So I'm Martin Sherrington. I'm the programme lead for Circular Critical Materials at Innovate UK. And fundamentally, to start with a controversial topic, but net zero is just not achievable without critical raw materials. And you might not necessarily understand what critical raw materials are, but you interact with them on a daily basis. And the clean and digital transition that we're currently going through at the moment to decarbonise our energy, our transport, our industry is fundamentally underpinned by these materials. And that includes your mobile phone, your televisions, your radios, your washing machines, your cars. They all have semiconductors, they all have electric motors, they all might have generators, they all have batteries, and all of those components or products all contain critical raw materials. Broken it already. So this diagram is getting a little bit out of date now, but this is from a foresighting study that the European Commission did about 5 years ago. And what it does show on the left-hand side is a list of materials ranked in order of risk. In the middle, you've got a series of key products that use those materials, and on the right-hand side are some of the key sectors that these materials are used in. And what you'll notice in the top left there is in very high levels of risk are the rare earth elements, so light rare earths and heavy rare earths. What are rare earths? Well, they are the bit on the periodic table that in your chemistry lessons in school you probably never get down to. Right at the bottom, it's the lanthanides. It's the 15 lanthanides plus scandium and yttrium. And the reason that rare earths are so important is one of their key applications is in magnets. It's rare earth permanent magnets, so neodymium iron boron or samarium cobalt. And magnets effectively are used in everything from traction motors in electric vehicles through to offshore wind turbine generators. Saying they're rare is a little bit of a misnomer. They're not actually rare. The challenge with rare earths is that they're actually quite abundant and they are in quite a lot of large mineral deposits, but they're there in relatively trace amounts. So the challenge with rare earths is actually how you fundamentally separate them out from those mineral deposits, and then you've got a bigger challenge as they're all quite chemically similar, sit together in the periodic table, and it's then how do you actually then isolate those metals from each other. And then there's another big factor to it as well, and it's the sort of the current big elephant in the room, China. So 70% of the world's rare earths are mined in China, and 90% of the global supply chain of processed rare earth elements are in China. The Chinese don't want to sell you an oxide or a magnet, they want to sell you a car. They've spent decades investing in the entire materials and manufacturing value chain to go from mine to magnet to product and out to us. And this has created a huge challenge, and in terms of these materials are now highly economically vulnerable and at extremely high risk of supply chain disruption. So what's the UK government been doing about it? So somewhere. There we go. The approach by the UK government has been evolving over the years, but back in 2022 saw the first critical minerals strategy for many years published, and this then saw the establishment of the UK Critical Minerals Intelligence Centre, run by the British Geological Survey, established as the UK Observatory for the space. In 2023, there was an industry-led task and finish group looking at industrial resilience for critical minerals, which was led by our very own Catherine Bennett, who's CEO of the High Value Manufacturing Catapult, you ever heard of if you went to into one of the keynote sessions earlier. And this identified six, I think it was six, there might have been seven, high-value manufacturing sectors that are all consumers of these products. And ultimately trying to understand where the gaps in the UK supply are. Last year, there was a few interesting things happened. So one, the British Geological Survey and the Critical Minerals Intelligence Centre updated the UK's criticality assessment. And we actually went from 19 materials and minerals classified as critical to 34. So the problem just got quite a bit harder. And then rather excitingly then, in December at Resourcing Tomorrow, Minister Jones announced that later on this year there will be a new UK strategy for critical materials. When the first critical material strategy was launched in 2022 and then refreshed a bit later on, that was when the Climates Programme was actually initially announced as a key delivery vehicle for the national strategy. So, spoiler alert. So the big question here is, well, we're doing all this, but how do we increase security of supply and build resilience for these critical materials, especially for rare earths? And it'll come as no surprise, there we go, to many of you. Recycling. So recycling is the answer. So what we can do is actually take advantage of the situation we find ourselves in, where we've been importing loads and loads of overseas products with loads and loads of critical materials embedded in their components. And that becomes a massive end-of-life feedstock opportunity that we can capitalise on. So in terms of where those secondary sources are coming from, so really there's two extremely big, I was going to say low-hanging fruit, that's probably not the right way of putting it, and then there's some other, so battery electric vehicles, so the SMMT, as of 2024, their figures are showing there's about 1.7 million electric vehicles on the UK roads at the moment, roughly with an average expected life of between 8 and 10 years. Every electric vehicle at the moment has in order of about 5 kilos of magnets. So if you do the maths, that's ballpark 7 million or so of feedstock. As it also happens, internal combustion engine vehicles also are packed full of magnets in their ancillary motors and all sorts of everything, the windscreen motors, but also from the speakers in your car, absolutely full of rare earths. So the actual figure is probably even bigger than that. The second big thing is UK government policy has been seeing massive targets in terms of deploying offshore wind as we decarbonise our grid. So by 2030, the current target is 50 gigawatts. An average offshore wind turbine has ballpark 650 kilograms per megawatt. So if you do the maths, you're talking a potential secondary materials feedstock there of around 30 million kilos, which slightly longer lifetimes, but over the course of the next 25 to 30 years, that material starts to come back. The longer term there, by I think it's 2050, I think the target is to have 115 gigawatts of capacity deployed. So, I mean, that's just then more than doubles what the current feedstock levels could be. The other big one is so waste electrical and electronic equipment. So sort of talked about mobile phones at the start, talked about televisions and radios. Loudspeakers and hard disk drives, for instance, are a massive source of rare earths here. And then you've also got huge opportunities as well to look at valorising other waste streams and looking at mine tailings, for instance, and land remediation. There's lots and lots of opportunities to recover rare earths and a lot more in between. So looking forward at the opportunity, so the British Geological Survey, as part of the Met for Tech Centre, which was a UKRI funded programme, identified that by 2040, rare earth permanent magnets at end of life could from electric vehicles and wind turbines, are forecast to actually equal expected industry demand. So what that actually means is if we start developing recycling capability now, the UK could actually, weirdly, find ourselves in a position where we could well be a net exporter of rare earth elements by the mid-2040s, which would certainly be a rather strange turnaround, but one that is a really interesting opportunity to go for. But then that takes us into, well, how do we realise that opportunity? So this is where it starts to get a little bit more challenging. So how do we develop a circular economy to make this happen? So there is, right down here, an obvious starting point of actually starting to look at design for recycling, work with the OEMs and actually try to design better products that are more easily recyclable to make the economics of recycling more efficient. But that's not a short and possibly even not a medium-term option. That's going to be a sort of a longer-term problem. So moving up, the first thing we've got to really do when products come to end of life is collect it, sort it, and disassemble it. But that's on its own is a massive challenge. So we've got to be able to actually do that disassembly in an economic way, and that's the fundamentally most difficult part of all of this. But once we have done that, then, well, before we do that, that actually opens up a series of rather interesting innovation opportunities as well around robotics, automation, AI and machine learning. There's huge opportunities to get innovative technologies involved to actually grow that recycling capability. Once we have sorted it and disassembled it, our options could be to go down to direct reuse and actually just take a magnet out and stick it straight back into a new product. That's not as easy as it sounds. It might be possible with sort of larger magnets. It might be possible in sort of offshore wind turbines, but unfortunately, manufacturers do have a habit of updating their technologies and redesigning things, so that might not necessarily be the easy one. Then we move on into, okay, so if we can't directly reuse it, we feed it into short-lived recycling. So can we go magnet to magnet? So in the UK, this is something we've got particular expertise around. So the University of Birmingham, back in the the 90s and the noughties, developed a hydrogen processing of magnetic scrap process using hydrogen decrepitation to effectively, I don't think Rob's in the room so I can say it, effectively they've created a massive washing machine drum, effectively that they can throw a load of magnetic, scrap containing products and effectively use hydrogen to effectively turn those magnets back into powder and collect that powder, press it back into a new magnet. So there's a company called Hypermag that are in the process of now scaling that technology up. But there is a downside, there is a catch with short-lived recycling in the product out is only as good as the stuff in. So if you want a high-quality magnet out the other end of that process, you've got to be putting high-quality material in, and that's another challenge in itself. So therefore, the other option is long-loop recycling. So effectively, take the magnet and turn it all the way back to its constituent metal oxides, and then feed that back in to the rare earth midstream to actually do the alloying and subsequent magnet manufacturing. This is a great process because effectively what it means you can produce oxide grades which are actually arguably more pure than virgin materials that are dug out of the ground in the first place. So it's a really interesting opportunity, and what we've been doing with the Climates programme, so Circular Critical Material Supply Chain, it's a £50 million investment over the previous 2 years or so, and there's still about another year or so to go on the programme. We have been focusing on rare earth elements for the reasons really that £50 million isn't a lot of money, so we wanted to make sure that we concentrate on getting the biggest bang for our buck, make sure we get a return on investment from that. But also we've been able to complement activities that have been going on with our colleagues in the Faraday Battery Challenge, who have been looking at battery recycling, have been looking at battery materials as well. And ultimately our aim here has been to seed growth of UK capability for a circular supply chain. So the vision of the programme has been to create a more resilient and sustainable UK by building a stronger supply chain of materials for high performance magnets, and position the UK as a world leader in rare earth metal recycling. In terms of the mission, so we've been basically looking to improve the security of supply of rare earth elements through 4 routes. So we are still looking at it from a full mine to magnet and then back. So we've been looking at sourcing, extracting magnets, processing them, manufacturing magnets in the UK, which is a particular gap in the UK supply chain at the moment, certainly from a sintered side. Recycling high-performance magnets as part of a circular economy, and enabling research into the next generation of magnet materials. And I'll come on to that in a minute. But ultimately, in doing this, we've been building networks of industry, investors, government, and the researchers to actually make this happen. There we go. The innovation themes that we've been focused on, so extraction, so digging materials out the ground in a much more efficient way, doing that beneficiation and actually taking it from ore and extracting out the carbonates and oxides. Processing, so investing in the midstream, looking at how we improve our midstream processing, improving that separation from mixed rare earths into separated rare earths, and doing that metallization and alloying. Looking at the downstream, moving into magnet manufacturing, so how do we make magnets more sustainably, but also how do we improve the performance of magnets. Circular economy, I've already talked about that. And alternatives then. So this is the sort of the counterfactual piece. So really interested in, well, what can we do to look to de-risk supply by not using rare earths, or substitute out rare earths, or find some sort of alternatives, which is actually not quite as easy as it sounds. So in terms of the programme and how we set the programme up, so we've had 5 pillars. So innovation, so funny enough, for an innovation agency, focused on identifying and investing in business-led R&D activities and looking at how we promote research to business knowledge exchange as well, to help grow UK capability. International, so recognising that we can't do this on our own, as we don't actually mine any in the UK currently, so we do need to build and develop key international relationships for collaboration and cooperation and knowledge sharing. Skills, so I think this has been a common theme in a number of sessions today, but it's the sort of the big elephant in everybody's room at the moment. If we're trying to build and grow a supply chain, we need people to man it. There's a big challenge there. And standards, so if we're investing in the innovation environment and we're getting high quality R&D through leading to next generation products, processes and services, we need to ensure that innovation environment is supported by appropriate standards, and working with our partners in government to ensure that policy and legislation is there to actually back up the growth of the sector as well. And the other one then, working with the investor community and ultimately looking to how we can unlock that private investment to again accelerate growth. So in terms of some of the delivery headlines of what we've done, in total we awarded 38 R&D projects to 52 project partners, and that was a £12.4 million grant funding investment with an £18.1 million total project value. We've also run 5 targeted innovation exchange challenges where we had 5 SMEs across the rare earth value chain set with some very specific challenges that they wanted solving, and we ran a process where we've ended up connecting those SMEs with business-to-business or research-to-business solution providers. We've also commissioned and are about to publish a series of innovation landscape reports looking across the breadth of the UK value chain, identifying where the key opportunities are to direct future R&D funding. From a skills side, we have had a strategic partnership with Explore Science Discovery Centre up in North Wales and Less Common Metals, and through working with them, we've managed to grow their Mine to Magnet STEM workshop, which had previously seen about 250 pupils a year receiving the training, and increased that up to 1,500, and we're looking to keep that relationship going and expand it a bit more nationally. From a standards perspective, we've worked with BSI, the British Standards Institute, to identify priority areas for future standards development. Indeed, there's a webinar available to look back on from last Friday if you want more detail on that. From an investor side, we've completed a barriers to investment report about 18 months ago, identifying where the key barriers are as we see at the moment. And we've also done a series of investor networking events. We've also run an investor readiness program as well, in partnership with our colleagues in the Faraday Battery Challenge, to prepare SMEs to raise investment. From an international perspective, we've also done a big piece of work looking at international benchmarking, and we're currently now working with colleagues across FCDO and DBT, and also internally with Innovate UK across our global teams, to actually help understand what we need to do going forwards, and hopefully get some more missions going. And we've also done an awful lot of work with the Canadians as well, including several missions, and also we've had a bilateral funding competition. So just to add a little bit more colour to what we have been doing, so just some project examples to run through. So the top one. It's a first-of-a-kind project looking at decommissioning an offshore wind turbine. So this is actually, I believe, a global first. We managed to, I say we, the royal we, but Magnumatics in the middle, electric machine manufacturer based up in Sheffield, actually produced a prototype offshore wind turbine a few years ago, and they offered that up as a bit of a test bed for European Metal Recycling, who led the project, to try and understand how to actually decommission something which is rather large, I think, to put a slight bit of an understatement, and working with Hypermag in Birmingham to look at how they can actually recycle those magnets, create new magnets, and actually feed it back into building a new machine to actually validate the use of short loop recycled magnets in an electric motor. At the bottom, so SG Technologies, they make bonded magnets. They're based down in Rainham, down in Essex, not too far away from here. They worked with ZF, automotive tier 1 manufacturer, to actually integrate recycled magnet feedstock into bonded magnets for use in power steering. So that project is due to come to an end fairly soon. In terms of more supply chain collaboration as well, so Ionic Technologies and Less Common Metals, who are both out in the exhibition hall, working with Ford at the moment to actually, the ultimate goal in this project is to actually produce a Ford Puma with a 100% recycled electric powertrain in. And at the bottom, a project led by Pensana, who are a UK registered mining company establishing a refinery in Humberside, have worked with Polestar, looking at ways to improve the ESG performance of their mining activities for primary sources. In terms of some novel processing sources and alternatives, so some interesting projects here on the sort of more left field side. So Mine tailings, Lithium Metals, who are currently scaling up a battery recycling facility up in the northeast. They have been working with the University of Exeter to see if they can apply their hydrometallurgical processes to actually recycle, to recover rare earths from mine tailings. The phytomining, so Fiona, spun out of Brunel University. They are basically using plants to bioaccumulate metals so they can do large-scale land remediation. Really, really interesting. Ionometallurgy for recycling, so Nanobox are currently in the process of scaling zinc oxide recovery, and they've applied their chemistry into rare earth space. And a bit more work to do, but it's looking very, very promising there as well. And then Materials Nexus, working with less common metals. So again, Materials Nexus are out on the show floor, and they've been using their AI software to look at doing materials design to reduce the use of heavy rare earths in magnets, as heavy rare earths are currently classified as conflict metals. So that's some of the flavour of what we've done in terms of the impact so far. It's looking very promising. So have we seeded growth? Well, the current evidence suggests that yes, we absolutely have. So our indicative co-investment at the moment is looking at around £174 million, which represents a 12-fold investment at the moment. Hopefully there's only one direction that's going, and that's up. And I think broadly then, where do we want to go? So our ambition really is to ultimately expand the scope of what we're doing, continue to build capability in the UK, but taking into account how we do carefully expand that material scope to reflect the new 34 materials that are on there. We need to understand how to prioritise that. We want to be able to use secondary material feedstocks to build security and resilience in the supply chain through circular approaches, and ultimately the long-term vision here is to actually make the UK a world leader in the recycling of critical materials, not just in rare earths. So, as I said, the British Geological Survey have increased the number of critical materials from 19 to 34. So what we've committed to doing over the next year or so is actually evaluate the current UK industrial landscape, understand what the midstream looks like, and identify where the strategic opportunities are for growth. We also need to identify where the priority materials are to direct future research and innovation funding. So hopefully we can take that 34 and reduce it down into a bit more of a strategically manageable chunk. So in summary, as I said at the beginning, critical minerals and materials do underpin net zero. They are absolutely fundamental for high-value manufacturing. The programme set out to seed growth in the rare earth space for a circular economy. I think we've done that, and circular economy approaches can absolutely enable the UK to have security of supply and increase our supply chain resilience for rare earth elements. So I think with that, I think there's about 2 minutes left. So, does anybody have any questions?
Does it work? Yeah. So you were talking about offshore wind turbines and the quantity of magnets they have inside. Have you also considered the cost of taking down those turbines in this? Because I heard in some countries they decided to leave them there. So recovering that material could be quite challenging. Thank you.
Yeah, I think if you look at it in terms of in the round, I mean, the magnets in a wind turbine are only one small part. You look and you think there's tons of copper, there's tons of aluminium, there's tons of platinum group metals and gold and structural steel, electrical steel. There's a lot more material to actually go at, which in theory will offset those costs ultimately. I think there's limited work you can do in terms of trying to extend the lifetime and life cycle of those turbines, but I think they will have to come back eventually. But yeah, absolutely get your point. So. behind you, Chris.
Critical minerals supply chains are very obviously international and geopolitical by their very nature. Are there any plans for kind of bilateral or international collaborations with other countries? Like Germany is doing a big collaboration with Australia at the moment. Is there something similar planned for the UK? Or is that on the roadmap?
Yeah, it's on the... We've done a big international benchmarking report and analysis at the moment. So we're currently working with colleagues at FCDO and DBT and with the global team at Innovate UK to help us understand what the art of the possible will be. But the UK is also a member of the Mineral Security Partnership as well, which you know is it's about 10 or 15 countries part of that at the moment. So yeah, there's a lot of activity going on to sort of get by and trilateral activities, especially in the innovation space. Right, I think on that, I think we'll, before we get kicked out, I will draw it to a close. But thank you very much. I'm going to go, I'll be around by the climate's poster anyway for the next sort of half an hour or so, if anybody's got anything else they want to come and ask me. But thank you very much.
Welcome to CEO Insights. I'm Marilyn de Guzman with Investing News Network. In this episode, I'm speaking with Tim Harrison, Managing Director and CEO of ASX-listed Ionic Rare Earths, whose magnet and rare earths development projects have been getting some attention lately, particularly in the context of emerging supply chains for the global energy transition. Hello, Tim.
Hi, Marilyn.
So let's start our conversation with just providing an overview of Ionic Rare Earths, your projects, and just your company's value proposition.
So Ionic Rare Earths is developing both primary and secondary supplies of magnet and heavy rare earths. We've got a large ionic adsorption clay deposit at Makuutu in Uganda, which is a development-ready, large-scale ionic adsorption clay, which is a type of mineralization which is prevalent in southeast, southern China and Myanmar. And it's those type of assets that produce, greater than 98% of the world's current supply of heavy rare earths. So it's a project that has the capacity to help, the new economy develop an alternative, secure, sustainable source of magnet and heavy rare earths, and recycling through a UK subsidiary called Ionic Technologies, which is now producing high purity separated magnet rare earths from end-of-life magnets, from wind turbines and other applications. And so developing that opportunity in Belfast in the UK.
Right. So speaking of, developing stable supply chains, geopolitical drivers are pushing the development of new supply chains, largely due, to reduce reliance in China. What do you see is your company's role in contributing to this process in securing supply chains for Western governments?
Well, I think, producing magnet and heavy rare earths from both primary and secondary sources enables us to be an early mover in helping develop the source of material for the downstream supply chain to mature. So providing an alternative source of magnet rare earths initially from our recycling subsidiary Ionic Technologies, which we can now put in the hands of supply chain partners to be converted from the oxides into metals and alloys, which can then be handed across to magnet manufacturers to produce the sintered magnets, permanent magnets, to go into electric vehicles, for example. And I suppose where we are now, recently, we've been able to talk publicly about collaboration that we're developing with LCM, so Less Common Metals, which is a metal maker in the UK, one of only less than a handful of metal makers that exist outside of China, being able to now convert that material into a tangible magnet that can be evaluated by our EV partner in this activity, being Ford. So yeah, tremendously exciting. We're able to develop those paths for value addition and take the material all the way through to the final component. And then once those relationships have been developed, we've got a large ionic adsorption clay project, which being development ready, we can bring to production very quickly to source that larger demand that will come once the capacity exists outside of China.
Right. And really, I guess government support is really key in this whole endeavor. And for your companies, from your company's perspective, there's been some big news that have taken place over the past few weeks. Across two of your subsidiaries, getting some very strong public support from government representatives. Could you talk a bit more about these two developments?
Yeah, so we've had a really big month. So I suppose fresh off the block is, I've just got back from 2 weeks in the UK where we were able to announce the collaboration with Less Common Metals and Ford in the UK with our recycling subsidiary, Ionic Technologies. That's been funded by nature of a couple of grants that we've received from the UK government. We've received tremendous support from the UK government and Innovate UK. So 2 grants to help us develop and demonstrate sovereign capability in the UK. And then another grant to develop the feasibility study and looking at the stocks and flows model across the UK to support a commercial facility in Belfast. So tremendous support. If we look at, going back to the start of this month, we had a conference in Perth, Africa Down Under, where we hosted a delegation from the Ugandan government, including the Minister of Energy and Mineral Development, where we received a public endorsement from the Minister stating that she was going to approve our mining license, and so we're patiently awaiting for the paperwork to follow through on the commitment from the Ugandan government to support the project.
So let's talk about that for a sec. The support from the Ugandan government on your project in Uganda. Can you talk more about the developments in that project, where it's at right now, and what are the plans moving forward?
So Makuutu Rare Earth Project, so we've completed a feasibility study which was required to support the mining license application. We submitted all the documentation, finalised that earlier this year. We've been waiting for mining regulations to be approved and gazetted in Uganda, which was completed at the end of August. So now with all the documents in, we're waiting for the award of the mining licence. We've got our environmental permits, so stakeholder management and engagement in Uganda has been tremendously strong. We've got support from the government on the development approach, and we're also building a demonstration plant at Makuutu now. So in construction with a plan to start producing mixed rare earth carbonate later this year. That's a mixed rare earth carbonate that's 71% magnet plus heavy rare earths. So it really is it's a market leading product. And because of the nature of that product, a very strong engagement from potential supply chain partners in Europe, North America, and Japan and Korea. So everybody, a lot of our potential partners are patiently waiting for us to get all of our documentation squared away from the Ugandan government before we can move on with the next phase of supply chain engagement.
The other aspect of your business is Ionic Technologies, which is your recycling business. Can you talk a bit more about what this technology is, what it means for your company's business strategy, and how the UK is supporting your Belfast facility?
So Ionic Technology's importance to Ionic Rare Earths as an overall strategy is to be able to start to produce high purity oxides from recycled material now, which we can then work with supply chain partners on demonstrating capacity and capability to go all the way through to sintered permanent magnets for applications across electric vehicles and wind turbines, for example. So the technology itself is a step change on a lot of the other technologies in the rare earth and magnet recycling at the moment, in that it's able to take magnets of varying quality. It processes the material via a hydrometallurgical process to individually separate out the magnet rare earths, which we can then take all the way to a high purity oxide and then provide those materials to the metal and alloy makers so that they can start to make the magnets with varying compositions of neodymium, praseodymium, dysprosium and terbium, for example, to make specific magnets for a multitude of different applications. So a lot of the other technologies at the moment in the recycling space don't have that ability to produce the high purity products. They produce a mixed rare earth oxide, which has varying compositions from one batch to another batch. And therefore, a lot of alloy and magnet manufacturers, especially those making the sintered magnets, will steer away from that material. So when we've presented our high purity oxides to some of our supply chain partners, it's the first recycled material that they've been willing to take, and it's been a big vote of confidence and endorsement on the technology and the products that we're able to achieve with the technology from Ionic Technologies. And then with regards to, I suppose, the support from the UK government, the UK government has identified that in order for it to be able to produce the products to compete and be able to develop their own advanced manufacturing industries, that they have to look at alternative paths to secure this material. Recycling of permanent magnets has been something that's been identified through various facilities within the UK government. Innovate UK, which is a branch of the UK government that has been set up to help develop these new supply chains, has been a big supporter of the technology that Ionic Technologies is developing. So the grants that they've awarded ourselves and our partners are all part of a systematic approach to be working towards a business case and a potential commercialisation of the technology in Belfast. Belfast is a unique location in that post-Brexit, it has the ability to participate in both UK markets and the EU. So with that dual market access to material from Great Britain itself, but also potentially materials available from the island of Ireland, mean that we have a much wider potential pool of material that we can source, and a much wider pool of potential supply chain partners that we can work with as we develop the business case and work towards commercialisation in Belfast. Additionally, the infrastructure in Belfast is absolutely fantastic, given deep water port and very visible wind turbine deployment and decommissioning that's underway right now. So, yeah, it's a fantastic location for us to be looking at commercialising the tech.
Yeah, that's an interesting point. Beyond this technology, really, beyond the UK market, have the potential to be rolled out globally. What's your strategy in terms of, is it just, just you're looking at the EU? What's the global strategy for this technology?
Yeah, look, we've had inbound inquiries from a lot of different corners of the world, to be honest, since we announced the products that we produced back in June. So we're evaluating that. We are very conscious of our ability to make sure that we can deliver what we've set out to achieve in Belfast, but we have identified several potential jurisdictions globally where we think commercialisation of subsequent cookie cutter recycling facilities could be developed over the course of the next few years. So tremendously exciting for the milestones that we've been able to deliver with Ionic Technologies. And over the course of the next few years, we do anticipate there being more than one recycling facilities under the Ionic Technologies banner, with supply chain partners similar to those that we're working with now. So really strong engagement from potentially Europe and North America, where we do have something that's very different from current recycling tech. And if we look at policy, the European Critical Raw Material Act mandating that, targets of 15% of these newly dubbed strategic raw materials, of which magnet rare earths fall within, needs to be sourced from recycling by the end of the decade. So we do see substantial opportunity for the technology to be deployed in Europe, for example, as a key market.
Right. And things seem to be developing rapidly for the company. Where do you see your company in 12 months' time?
Yeah, look, at 12 months' time, I anticipate that we're well on the path to commercialising the tech in Belfast. We anticipate that on the back of one of the grants that we've recently received, we'll have a feasibility study completed with a business case and a very good understanding of the potential scale-up of what that looks like in Belfast. And if we look at Makuutu itself, over the next 12 months, we've got obviously the award of the mining licence, which I hate to use the word imminent, but we do expect it very, very shortly. We've got a demonstration plant that's in construction now, so later this year we'll be producing mixed rare earth carbonates. And given where we are as the most advanced ionic adsorption clay project in the Western world with product that's not committed to China, we do see our ability to commit to some of these new supply chains being announced over the course of the next 6 to 12 months. So tremendously exciting for where we are as a business and the hard work that's gone into getting to this point.
Well, all the best to your company or for those, upcoming developments. Thanks, Tim, again for joining me today and sharing your insights.
Thanks, Marilyn.
And thanks, everyone, for watching. Join us again next time for another engaging conversation on CEO Insights. If you like this video, subscribe to our YouTube channel and turn on notifications so you don't miss any new updates and interviews from Investing News Network. Until next time.
Hello and welcome to this video update from Ionic Rare Earths. We'll be hearing from Mr. Tim Harrison, the Managing Director, regarding the announcement just made that the UK government has agreed to fund Ionic Technologies partnerships and awarding 2 grants with a combined value of $2.46 million. It's a great announcement and we're looking forward to hearing more on the detail. Over to you, Tim.
Thanks, Peter. Yeah, really positive news overnight out of the UK.
And so let's talk about the size of the funding and the process it took you to get to this point.
Yeah, look, the funding that's been awarded overnight, we've been waiting on that being made public now for a little bit of time. Given the change in government in the UK government is now ready to announce the second round of climate's funding. So we applied for that earlier this year on the back of what's been a very positive engagement and degree of support that we've had from Innovate UK. So this second round of grants under the Climates 2 program, Ionic Technologies has been successful with 2 projects. First project, Reevaluate, is a collaboration and a partnership between Less Common Metals in the UK and Vacuum Schmelz, which is a German magnet manufacturer, to take end-of-life material from Vacuum Schmelz and convert that through our process back to high-purity oxides, under which then Less Common Metals take those oxides, convert them to metals and alloys, and provide that back to Vacuum Schmelz. And that's all part of a 100% recycled rare earth permanent magnet initiative across the 3 companies. The second project, Magnostic, is a partnership between Ionic Technologies and MPI and Swansea University in the UK to look at new technologies and commercialisation on new methods of demagnetising magnets used in, for example, offshore wind, and how we can develop new processes that can be an enabler or better ways of decommissioning wind turbines.
And Tim, let's talk a little bit about these two funding partners, Less Common Metals and Vacuum Schmelz. What's their profile in the decarbonisation or the climates program that the UK government is working with?
Yeah, so Less Common Metals has obviously been a partner with us on a number of initiatives. We had the first round of climates funding, which was announced last year, was a partnership between Less Common Metals and Ford on developing a UK supply chain. So Less Common Metals are one of the less than a handful of metal and alloy manufacturers in the rare earth space that exists outside of China. And Vacuum Schmelz is one of the largest magnet manufacturers outside of China as well, based in Germany. They've got a long history of rare earth permanent magnet production, and really is one of the leaders in that space in Europe. So two tremendous partners to work with as we demonstrate our technology, working closely with those partners, those incumbent partners in the supply chain, to unlock that UK-European opportunity.
And Tim, the UK government selected Ionic Technologies in the Magnostic collaboration. So obviously that means that Ionic Tech must be a leading player in this field in the UK.
Yeah, look, I think certainly on the back of what we've been able to achieve in the UK, the engagement that we've had from stakeholders at UK government level, Innovate UK, and the Advanced Propulsion Centre, we've really positioned ourselves quite well to be at the forefront of opportunities. And we're heavily engaged with the government there in talking about how we can commercialise the technology and look at other opportunities to enhance and improve the offering from Ionic Technologies in combination with other companies in that space to be at the forefront of recycling rare earths and helping the UK to develop sovereign capability. So, we do enjoy a very good relationship there. We enjoy strong stakeholder support across the UK and stakeholders in Northern Ireland. So we really have positioned the company quite well in that market.
And Tim, we hear the term supply chain talked about a lot. Securities of supply chain for the Western world supply chain for rare earth products for a number of different technologies and industries. You really are now leading that supply chain story, not just talking about it, but actually participating in that.
That's right, Peter. We've been putting a lot of energy into selecting partners in the supply chain who we think we can work well together, we can be complementary with, and we can work together to unlock latent capacity that exists outside of China. And unlock that latent capacity with access to high purity, non-Chinese magnet rare earth oxides. So, we have been able to progress a number of discussions now towards partnerships and working now towards the commercialisation of the opportunity in Belfast. And on the back of that, leveraging those relationships into other key markets and jurisdictions like Europe and North America, where again, you do see the same partners popping up time and time again in ways to bring that technology to Western markets.
And Tim, Ionic Technologies can supply rare earth oxides today, not years down the track. You've got a trial program going already. How hard it would be to scale up to meet potential increased demands?
Yeah, Peter, we're making high purity oxides now, and we're on the cusp of delivering and completing our delivery of high purity separated oxides as part of the program with Less Common Metals and Ford. So we are making product and we are looking now at how we can leverage that product into other relationships, other partnerships, and hopefully we'll be in a position to talk about those again soon as well.
And Tim, where will Ionic allocate the funds that have been awarded here in the near term?
So all of it's going into Ionic Technologies. technologies. As a company, we do see this as being near term, close to commercialisation. And I think what we've also seen is the appetite from the market on a scalable, sovereign capability that we can put in the backyard of Western governments as being something that is a big unlock for Western supply chains. It isn't dependent on the development of mine. We can start supplying high purity separated oxides immediately from the materials that are common in a number of these Western countries. They're waste materials, they're end of life materials. We can unlock the latent capacity, the rare earths within those end of life materials, and convert that back into the oxides, which then can go into metal and alloy magnet manufacturing. So, yeah, we're in a position to scale. We are ready to commercialise in Belfast, and we're heavily engaging with the UK government on what that's going to look like.
So, Tim, obviously a significant recognition and confidence here by these partners into Ionic Tech. What message do you want to leave with shareholders today?
Look, I think the rare earths market is a challenging market, and as we have done the work on the supply chain all the way from primary supply and mining and separation, we do see the recycling moving at a faster rate towards commercialisation because of its ability to move independently of both mining and separation capability. So we, as a company, are very, very keen to accelerate and push into this recycled market and leverage our product into relationships and start to develop those Western supply chains. So I suppose my message really is that, this is an endorsement from the UK government, another positive mark, and a reflection, I think, on the nature of the discussions that we're having in that market, moving towards commercialisation, building a commercial plant in Belfast and being able to scale this technology into Western markets.
Thanks, Tim. Obviously, a significant recognition, a great catalyst for shareholders to recognise, and we look forward to hearing from more updates from you in the near future.
Thank you, Peter.